Thank you. That's a very generous and detailed introduction. I'm Qian. Very nice to be here. Like you mentioned, I'm an interaction design researcher, and I'll be speaking to you about HCI and AI. HCI, I'm very much an HCI design researcher. That's a subfield of HCI that studies how human beings in the real world use technologies that we create in research labs today, and how we can use that human understanding to inform opportunities for technologies, to inform how we build systems. And my research focus is very much on AI systems, machine learning systems. And I want to just show you at a high level what I do. I know many of you create novel AI systems, try to increase the capabilities of AI models, systems. But what I do is I take what you create and try to understand the full range of things people do with these systems, and try to think how can we maximize the value people experience from these systems. And we use these to also try to understand do the user's behavior inform us new opportunities about AI? I know this sounds somewhat abstract. I will start with a case study, show you a concrete example of what we do, and then I will come back to the question, this larger question of why we want to go through this translational process. And the title of my talk is Making AI the New Electricity, and I will also talk about why electricity is the sort of ideal user experience that we try to push for. So this first project, this is a collaboration between the CS department and the biomedical engineering school at CMU. It started about 6 years ago. A group of biomedical engineer researchers came to talk to us, want to build a machine learning system that helps with a difficult clinical decision, which is whether and when to implant an artificial heart to an end-stage heart failure patient. So this artificial heart is basically a mechanical pump that surgeons perform an open heart surgery, open up the heart, put a mechanical pump into the heart, and the mechanical pump will basically do the job for do the functionality of the heart for the rest of the patient's life. And there is a tube coming out of the patient's body linking to an external battery. So it is the doctor's decision to first identify patients who are sick enough to be able to benefit from such an aggressive therapy. And second, patients who are not too sick to survive such an invasive surgery. And third, they want to identify patients who are responsible enough, who have enough social support to take care of this permanent wound, and don't forget to charge your battery. And this is, of course, a difficult decision. So we thought, machine learning can help. And these systems can mine patterns of previous implant patients, their medical history and outcome, and and can predict the likely outcome of each patient's implant. And these systems typically look like this, and this is also the kind of design our collaborators were working on. You put in a list of patient variables, click enter, and you see some predictions on the surgery outcome. However, most of these systems in the past 30 years kind of failed, which is probably too strong a word, in clinical practice. Doctors simply don't use them, despite the fact that these systems are quite accurate in research labs and across various studies, various evaluations of their performance. So what we chose to do is we spent 3 weeks in 3 implant hospitals across the U.S., implant centers of different sizes, and trying to also ranks differently in terms of surgery outcome. And we interviewed clinicians across clinical roles and across rankings, followed them day and night, really try to understand how they take care of patients, how they make their decisions. And finally, it's quite interesting. They don't really find the implant decisions that difficult. They basically tell us, you just exhaust every other option. When no other medication works, you put the mechanical heart in because it's the last option available. So there is no such a moment for decision making per se. What they do is instead every day, every morning, they visit their patients, talk about whether they want to adjust the medication or not, or do they want to proceed with implant. Decisions happen over conversations, really briefly and incrementally. And of course, these kind of conversations happen very differently across different hospitals, but depend on the sort of social dynamic in different healthcare teams. The only sort of shared practice in decision making, I think it's really interesting. I want to show you, just to imagine this room where doctors have their weekly interdisciplinary decision meetings. This particular meeting, the whole people sat around a long 40-seat long table, which really reminds me of Harry Potter movie. If you know what I'm talking about. Above us, there are 4 grand chandeliers hanging over the table. On one end of the table, there's a portable projector, nothing as fancy as this, projecting the electronic medical records on the score, and apparently people sat according to their ranks. So attending cardiologists, surgeons, senior physicians sat on one end, and then you sat across your rank. The social workers, nurse practitioners, people who operate computers, who do the paperwork, sit on the very far end. They not only very rarely participate in the discussion, they cannot even see the screen. I, as an external guest, they kindly put me on the 4th row. I really couldn't see what's going on the screen. It's very much an environment designed not around computers, but around the few powerful decision makers. And I think that is really interesting. Once you sit in that room, you can really see why nobody would go up to a computer and say, hey, let's think what the AI might say. So with these observations in mind, we designed a very different kind of decision support system, a system that takes the form of a meeting slides generator. It automatically pulls out patient's information from electronic medical records, populate the slides presenting the patient case, and then squeeze AI prediction in the little corner of that slide. It, of course, doesn't necessarily need to be a slide. It can also be a printout, because a lot of the hospitals still are very much paper pen-based, sort of follow a paper pen sort of practice. And this is really interesting, because when we present the AI prediction in this way, doctors do not feel threatened anymore. They don't think, oh, the AI want to do my job. My job is going to be automated somehow. They look at this and think, oh, AI is just the machine learning prediction is another representation of the patient's condition. Just like the medical history, just like the blood test results, these are different facets of the patient's information, and they are inviting me to make a decision. And once we present the information this way, the attending cardiologists, surgeons, those decision makers became much less resistant to the idea of an AI. But much more importantly, because the system provides an output that's portable, that very much can accompany through their decision-making process. They can go to see the patient and would have a piece of paper at hand, but still have the AI prediction in the corner. More importantly, when they present the slides, when they present the patients in a room like this, in a room with 4 chandeliers and 40 people in a room, and if the doctor is making a decision that's somewhat contradictory to AI's prediction, it puts some subtle social pressure on the physicians. They somehow would feel like, oh, I need to rationalize my choice a little bit more. And this is critical. And when we brought this system to and used, of course, fake patients or like retrospective patient data in 3 hospitals, a different set from the first study. And the mid-levels, those nurse practitioners, social workers, they recognize the value of this tool right away. They all came after us and say, when can I deploy it? Because now they have something to point to. When they have a disagreement with their boss, they can say, hey, it's not that I'm disagreeing with you, but why, can you educate me on why the AI thinks differently? And this is critical. It is through this social mechanism that we can elevate the power, the value of AI's meaningful disagreements, and only AI's meaningful disagreements, elevate this information to the true decision makers. I really like this project as an example for this translation, when we are building AI systems, we very much think of as how do we demo the capability of the system. But when these systems move into the real world, it can take a very different form. And when we perform this translation, we can really amplify the value of AI. Now, our design, this slide builder idea is somewhat weird, somewhat unorthodox. You don't see many such designs in research because the majority of our community very much focuses on improving the prediction and communicating the prediction accurately to the doctors. And that is hugely valuable. But what we try to do with this slide builder idea is to recognize there are simply too many factors, too many social complexities, the patients dealing with a life and death decision, the doctors dealing with all the weirdness going on in the room. There are simply too many contextual factors to fully take into account an AI system. So instead, we try to think, how can we utilize these social factors, the social dynamics in the decision meeting? How can we use that as a material for the interaction? We were not trying to build a better AI, more accurate AI system per se, but we're trying to think, how can we increase the thing that people plus the AI can do? And this is important because particularly in this case, for example, people often say, oh, doctors are arrogant, they don't take AI's advices. But you also need to think about these are people who will open up your chest, put your heart on a pause, and then put a mechanical pump in. These are the people, like they have to be hyper confident and very assertive and very confident in their own judgment to be able to do that job. They cannot easily be swayed by AI, understandably. But what we try to do is to create an environment that stimulates them to make a better decision, at least a more reflective decision. Now, these two perspectives, I think, really go hand in hand. By making an AI that is more acceptable, we can actually get a lot more information about how to make a more accurate AI system. And I want to just show you a couple of quotes from the doctors when we showed the slide, the decision support tool at the decision meetings, their responses. So if you notice in that slide, the prediction says for that particular patient, the patient will die have right heart failure after 21 days after the implant. And this surgeon asked, is that 21 days from today? If we're going to lose the patient in 21 days, can we just wait? And I really want to point out this interesting notion of wait. I think when we build clinical machine learning systems, we don't often think about this idea of wait. For us, it's either implant or no implant, treatment A or B or C. But for clinicians in their day-to-day practice, their decision is often, do I implant him now or do I wait and see? Or do I try something else and see if tomorrow will be a better day? There's this interesting dynamic between predicting what will happen if I implant now versus what will happen tomorrow and what will happen if I implant tomorrow. There's this chain of decisions that are all very interesting in terms of time series and events. And these really point to very interesting directions for machine learning researchers to give a new perspective to look at the same set of patient data. Another thing that come out of this study is that the slide builder idea is very much generalizable. When we talk to the surgeons and clinicians across different disciplines, they're talking about all these diseases. Actually, you can all use machine learning and can all use a slide generator idea because these are all last option surgery treatments. Because it's a last option surgery treatment, usually the disease is so severe that the patient problem will involve more than one organ. Therefore, they need a team of interdisciplinary clinicians. Therefore, they need a full room of physicians from different departments. And in that case, the system can very much be reused in many different kinds of clinical decisions. And by looking at this structural similarity, we can also try to find different data sets and similar learning problems across disciplines. And this is, I think, really very rare in clinical machine learning. I don't know. Could be. Can you say it out loud?
Chronic obstructive pulmonary disorder.
Sorry, I cannot hear you. What's the question? Yeah, let's take the conversation. Cool. So it's in this sense that I think this project really gives a good example where when we try to look at different ways people use a simple system, well, not simple system, but like simple interactive system from an interaction point of view, we can also see new opportunities in building machine learning systems. Now, this project took me 5 years. If you're familiar with IRB, anyone does clinical machine learning work? Lucky you. If you're familiar with the legal work and the different data restrictions in terms of getting access to these life and death decision-making rooms, it takes a long while. It takes a lot of effort to get to understand how these doctors basically have their day-to-day lives. But it is absolutely critical, I think. And I want to just share an analogy to help you understand how I see this. Let's walk down the memory lane. And back in the 90s, when computers were just coming out of research lab, coming out of workplaces and starting to enter homes, a group of HCI scholars, most famously Mark Weiser, Peter Tomey, and others, raised this vision that we nowadays know as ubiquitous computing. And I love this quote, and I'll just read it to you. For 30 years, most computers designed have been headed down to the path of the dramatic machine. Its highest ideal is to make a computer so exciting, so wonderful, so interesting that we never want to be without it. He was talking about desktop computers very much having its own universe. You have a dedicated monitor, you have a fixed set of interactions that you would only perform when you're in front of a computer, right? And he said, we're trying to conceive a new way of thinking about computers in this world. The highest ideal is to make a computer so embedded, so fitting, so natural that we use it without even thinking about it. And crucially, he was not just talking about the physical presence of computer. He was talking about the cognitive presence of computers. Peter Tomey said the most remarkable technologies act like electricity. It is so central to our everyday life, but it requires zero cognitive attention from us. Therefore, we use it without thinking about it. Its remarkableness can only be felt when we don't have it. And these are truly visionary ideas because when we put the computer in the environment people operate, it's not just to say, oh, make using computers easier or more user-friendly per se, but computers can do more things that they couldn't do when they're just a standalone system. I bring my phone everywhere because it can detect location, my hobby, has all kinds of data about me, so they can serve my intent much more intuitively than, say, if I had a desktop computer do. And I think it's very much the similar idea. I think when we situate the AI in the clinical machine learning case, when we situate the AI in clinicians' natural daily lives, the AI can collect a lot more data about the clinician's intent. For example, the slide builder, if we can embed that in practice, then it can collect more data about what kind of patient cases do clinicians discuss more? What kind of cases do they weight it upon? And across different discussions, What are they waiting upon? These really collect a lot more nuanced data and a lot more information about how AI can serve clinicians better. And these are possibilities that we simply don't have access to with just electronic medical records data. I would argue AI as a whole, especially in critical domains, is at the cusp of a similar transformation. We have these remarkable systems, increasingly powerful. If you look at news headlines nowadays, there's no lack of dramatic moments, but how can we make these powerful systems so fitting, so natural that we use them without thinking about them? That is really a critical task for us. So in our latest Kai paper, we try to outline this problem space. From the very left, let's say, use a clinical machine learning example. Again, from the very left is the capability to predict intervention outcomes, and from the very on the very right is what value do the clinicians see from the system. By situating an AI in the process of their practice, natural practice, we can collect a lot more data about the patient case, about rare patient cases, about doctors' error correction interactions. We can also get a lot more contextual data, social information about the patient, for example. These are things, these are opportunities that are simply not available to us at the moment, and I think will become increasingly important as machine learning systems become more and more data hungry. The same structure, though, also reveals a new problem space, or reveals a problem space that is a thing we don't typically talk about right now. For example, if we're thinking about fairness or explainable AI, explaining how the AI algorithm works is really just the first step. How do you explain how why AI predicts this outcome based on the transformation and the data it collected over time across different users? This larger problem space is really important, and it can work both ways. So one of the questions that I more recently have been grappling with is, how can we harness the power of people? How can we make sure people create data, create training data, create contextual data, runtime inputs that can push the AI performance to the better and help them provide more value to people, and while minimizing the unintended consequences? Now, this is really sort of a new problem space, I would say. If you think about how user-generated data interact with the system, this really requires intimate collaboration between HCI people, or people who have deep understanding of human behavior patterns, and the people who have really deep understanding of algorithmic process. And also, this process can be very long. If you think about some of the most extreme examples of AI failures, TAE, for example, these are the systems really performed really well in research labs. You didn't get much unintended consequences when you were prototyping it, but it's out in the wild. Over time, you see more sort of outlier behaviors. So this really causes, but we as researchers typically work on the very left end, right? We work on the minimal viable system and to prove that we can learn this thing. We don't really care too much about how over time its behavior is going to change in the wild. So some of the things we have been, so we take a slightly different approach to studying this question. We started with studying industry practice. We go out and interviewed HCI and AI researchers, AI product innovation teams, and to understand how these experienced designers and engineers worked on these problems. And that's really interesting because we're already seeing a difference in practice. Traditionally, you see engineers create a demo system, and then designers take these systems and try to think about how to make it more usable to the users. We're seeing a different practice in AI products. For example, a team of a email inbox, like a predictive texting app, they would first come together, AI engineers and the HCI designers would come together and say, okay, let's think about how to create a feature that can help users give a more abstract, how can it help the system to process more abstract user instructions. And they just stop there, and then the engineers go to find their data sets to collect the labels for their data set and think about what are the abstract instructions from an AI perspective that they can process. And then the HCI practitioners go to the field, interview users, and try to understand what are the instructions people actually give, what are the sort of responses they're expecting. And then they come back and think about how do we create a product that collects these data for us over time. And they release these products and slowly collect new data. It takes 4 or 5 years to realize this feature over time. And I think this quote really summarizes this well. The difference between making an AI application and a non-AI application is that it feels like building a feature versus building a framework. Every time you collect more data, the data drives the next round of innovation. It is an ongoing process. So we really took a lot of inspiration from these processes in our teaching. We also try to put we have taught AI design classes and put half CS students, half AI students, half CS/AI students, and half HCI and humanities students together, and try to work together to create AI systems that are both deliver good user experience and curate good data for AI systems. We also have done some early. I'm just going to show you some early work from a research side. Happy to discuss with you more. These are really very early preliminary work. One of the systems we've been building, that project started a long time before I started PhD. It's an application similar to Google Maps. It's a navigation app, but primarily for blind users. And the traditional user interface design is quite typical. You identify a typical task flow and design a sequence of user interfaces. And then these interactions, of course, create data logs, and then the data scientists will come to mine those logs and try to find the things you can predict with that log. We wanted to push for a different practice. Instead of releasing the UI as a linear sequence of actions, we want to pre-identify opportunities for prediction. For example, we know certain travel patterns that people commute. So every morning, the behavior pattern is quite predictable. Can we identify these opportunities for machine learning early on? And then intentionally collect all the contextual data that can potentially make this prediction happen. And also, can we design an inaction of error recovery such that every time the predictive model makes an error, we can automatically detect that the user is correcting this error and what the correct label should be. Through such an inaction, we can create a system that's, although it's a very basic functionality, adaptive user interfaces, but it self-improves, and we don't need to posteriorly mine data patterns. Now, this idea of designing interactions as an interface for collecting data really generalizes to all kinds of interfaces. If you think about it, we're designing a service bot, and the chatbot is very much also an adaptive interface. We can still mine people's conversations and find out these things that represent people's behavior patterns, and then identify contextual data that can inform that prediction. Very much the same idea. Now, extending this idea a little bit more, one summer ago, I was at Microsoft Research, and there's a team of NLP researchers working on generative texts, and they wanted to embed this system into their Microsoft Office suite. But there's a problem. You cannot ever collect enough data predict every possible next sentence people are going to write, say on Microsoft Word. You just don't have that much data. But we have this capability. We know if you have appropriate training data, you can very much predict the next sentence or so. So the task for me was to understand what kind of feature do people even want? How can we avoid problems like Clippy? How do we make sure you're not overstepping user sense of authorship? So the thing, so we created this sort of a plug-in and recruited some amount of participants, and they take the plugin back home for a certain amount of time, writes their own documents with this plugin. This plugin does a very simple thing. That is, whenever you type a certain string, it leaves a note. So you very much a placeholder function, but this placeholder function tells us so much about what generative text is valuable to people. This is a real text from the study. For example, this person is writing a work document, and he said the first paragraph. The placeholder says intro paragraph that's not too cheesy. So we can tell a lot about this. After they replace this placeholder with the actual text, we can already tell a lot what the author was trying to achieve with this text, right? And we can still use the same methods trying to find all the relevant information in the same document and also in other documents available online. Think about what are the contextual data that can inform this intro paragraph that's not too cheesy. And we also created a Wizard of Oz prototype, such that after a while, after a few moments, the user typed this placeholder, they clicked on the placeholder, and they can see a simulated machine-generated text. And we got a lot of feedback. These responses represent different ways of providing feedback, providing the generated text. For example, some of them are search functions, some of them are topic modeling-based sort of methods. But in this way, we can get early responses from the authors about how do they feel about these texts. And I want to, again, show you a couple of quotes. This person said, oh, I really liked this scaffolding, this machine-generated text. But that's not usually the real point they're trying to get. Whenever people say something, the real meaning comes 2 paragraphs later, because it's always about seeding the idea that comes later in the document. And so they were like, I like this text, but the AI needs to show me more. And I'm like, I don't have more. I generated 1 sentence for you, no more. But this is really interesting idea of what counts as context and what's the relationship between, say phrase level generation versus paragraph level generation. Is this plagiarism? I got asked this question quite a lot, and there's an interesting relationship between what text the machine is generating versus what they see as stepping on their own sense of authorship. For example, when people are still writing their brain dump drafts of whatever document they're writing, any generative text was considered really dangerously stepping on their toe, because they're very much thinking about the idea behind their writing. However, after they've written either their outline or sort of the brain dump version of their document, when they're finalizing their writing, they very much welcome machine suggestions, because they think, oh, the ideation stage, the core intelligence of my writing has already been there. The machine is just helping me, fleshing it out. And I think these issues are really important for us to understand early on in the process. And what we do through this tool is really first trying to identify the things machine shouldn't do, and then collect the data for those opportunity features. And then through those, for example, the placeholder functions and through logging those data, we can also curate the data that in the future will inform a much larger, sort of much more performant system. And it is through this idea that we want to create, I think very much demonstrate the idea that AI can be the next electricity if only it requires very little cognitive attention of us. It doesn't overstep. It doesn't do things that's counterintuitive, and so on. Now, this is, of course, a large amount of work. If you think about how we, as a field, transformed from desktop computer to ubiquitous computing, we did a lot of ethnographic and design work to understand how people behave. Where are the nitty-gritty pieces of life episodes that could benefit from computation? And then it also triggered a new wave of technological advance to think about how can we create technologies that deliver value when and however people want it. A lot more interaction design innovation that is apparently still ongoing today, and it is through this iterative process we really can transform what computation means for people in their daily lives. We're not yet quite seeing that in the field of AI. Now, this is an analysis of HCI publications, which is the HCI community of ACM. So already a community that very much cares about how technologies touch human. We're seeing a lot of advances in the algorithms. We're seeing quite some advances in how to model human behaviors, how to use machine learning as a tool to understand people, but much less work on how these tools can deliver value. How can we have the systems that power our recommenders or adaptive UIs have progressed from linear regression to all kinds of fancy learning algorithms, reinforcement learning, deep learning, but they're still recommenders. Are there other more important, interesting things that we can do? Are there new forms of AI that we're not yet thinking? And this is very much the goal of my research. Hopefully, we'll create a future where AI is everywhere, yet perceivably nowhere. And, oh, I do. And this is the end of my talk, and saved plenty of time for a question. Thank you.
So we have some time for questions.
Sure.
So with the medical field study,
Mm-hmm.
how can you apply those learnings for the rest of researchers who might not be able to go out and do a field study like that?
Mm-hmm.
Probably takes quite a bit of time to learn.
Yes.
And so, what kind of learnings did you get that you think would be applicable outside that other researchers can keep in mind?
Yeah. So the question is, what can we take away from the field study, the clinical field studies, particularly for those who don't necessarily have the resources to go out to the field? That is a great question. Not every project that I did was like that. If so, I probably wouldn't have survived. But I think the key takeaway there is to identify the important contextual factors that are going to affect how people use or perceive the machine learning system. For that particular case, because the social context, how the clinical team work together is so important, and how the physical environment of the hospital is so restrictive, that necessitates such a field study. But for a lot of other machine learning systems, you don't necessarily need to go that far. For example, in writing, you really don't. It's not necessarily valuable to go out to like people's homes, for example. But it is important to recreate that cognitive context in which people operate. That is why in the writing study, we very much emphasize we need people to write their own documents. Because when you give them an assignment and give them a topic, ask them to write an hour, the cognitive process is very different from when you're writing something for yourself. I think that's the sort of takeaway for sort of general machine learning research. Cool. Mm-hmm. Yeah. I see your point. The question is, will doctors become submissive to AI, and does that create unintended consequences? That is a wonderful question. So one of the observations we had in the second study was that, there was a different treatment. It's a less aggressive implant, mechanical implant. Somehow there was a I'm trying to think what's the surgery. Anyways, there is a surgery where the American Heart Association has an official machine learning model, so that surgeons' performances are evaluated against the machine learning prediction. And in that case, we really saw surgeons would always start their meeting by having an AI in the front and center of their room, and because they want to calculate how well this taking on this patient is going to affect their own performance evaluation, basically. And I think it is really a critical question for us to ask: is that the future that we want? Is that the role that we want AI play? It was not yet a problem for the heart implant case because the resistance was so strong. We're very much even just trying to crack into their minds. That's why this was not part of the discussion. But down the road, I definitely see that as a critical discussion to have. Okay.
If you have thoughts about the difference between soliciting feedback from people who might use a technology versus presenting a technology to people who might not know how they're going to use it until it's there. Do you have thoughts about that? It seems like that tension, if you're promoting ethnographic research to guide technological development,
Yeah.
it seems like it might happen the other way around.
That is a great question. None of these studies are dealing with people who know what AI is. It is very much what we call it ethnographic work of the future.
Yeah.
It's again about constructing that context, put people in the environment of a future, of an envisioned future, and then based on their reactions and try to see, is that really a future that we want?
Yeah.
Now, this of course has a lot of limitations because it's difficult to put people in that mindset, but that's what we try to do to recreate that. I think in NLP it's relatively easier. In clinical world, it's a very different story. Oh, okay. Sorry, can you say that louder? Is there any particular study you want me to talk about? The answer is it varies. Everyone has different levels of familiarity with machine learning. Oh, yeah, okay. I see what you mean. So the question is, how do we make sure users create data that improve the system rather than harm it, right? That is a great question, and I can see you will get very different responses from different people. But if you ask me as an interaction designer, everything users do is correct. The responsibility is in how we design interactions. How do we make sure people cannot do things that are going to harm the system, or it's a lot of hustle to create wrong labels, for example. But makes it a lot easier for them to create correct labels, and it's through interaction that we mitigate this process. Sorry. If you ask me, yes. But again, it's a balance, I think. In our experience, users' lack of knowledge of machine learning actually doesn't make the interaction design that much more difficult, because we know what data we want from them, and we can create interactions to stimulate that sort of behavior. The more difficult part to take account of is usually users have some misunderstanding of AI, and that's the sort of thing we cannot quite control because everyone has different misunderstandings. And that's the part you probably will need a little bit more work to get to understand the user's perspective a little bit better. Cool? Oh.
Yeah, so you mentioned that you want people to create richer training data, which is more useful for AI systems. So especially in NLP, there's this big problem of crowdsourcing data sets.
Mm-hmm.
Because people find the tasks very boring and they don't want to do it.
Yes.
So do you think that the way forward is to like find out what exactly people want from their AI application and then try to crowdsource that because they're more likely to do it?
That is a really interesting question. So I guess the interactive machine learning part mostly come later, like unsaying data instances, error correction, runtime inputs, and so on. For the initial training data, of course, slowly sort of accumulated data is a way. But we have also looked at other possibilities. I was talking to some students here working on fan fiction data. That's, again, a really good example of, like, there's just this data out there. How can we get the most value out of this data? And one of the projects that I've been working on is I was interviewing fan fiction writers and trying to understand why they're writing, what's the thought process behind their writing. Because you always have much richer cognitive activity going on beyond the text you put on, eventually submit, right? So that's another approach, trying to think of how can we get the most value out of existing data sets. And since you have some time left. So in that adaptive UI case, we deployed the system for 18 months, and I want to just show you the users generated data. The y-axis is the amount of users we had, and the x-axis is the amount of logs they create. If you see the very extreme, we really had users who just sit in front of the bus stop and just log the bus arrival time. I don't know why they do that, but they do. And in our experience, in every application, if it's interesting enough, you always get that peak. There are some really enthusiastic users. And how can we make sure, how can we make use of that data? I think fan fiction is just an extreme of people's passion for certain cultural phenomena. So how can we utilize that data? It's not just something that, we don't want them to be overrepresented, but also think about the value in that data. What? Yes, exactly. That's our sitting and logger bus arrival time user. I don't know why he does that, but really interesting phenomena. So, cool. Thank you. Really appreciate it.